Hey guys, today we're going to be looking at Leetcode 733 flood fill. We're given an image represented by by n grid of integers, and this image is called image, where image ij represents a pixel value of the image. You're also given three integers sr, sc, and color, and your task is to perform a flood fill on the image starting from the pixel image sr, sc. So that would be our starting pixel. And we're taught how we have to perform a flood fill. So if you're unaware, there's four main steps. We need to begin with the starting pixel, change its color to color, perform the same process for each other pixel that is directly adjacent. So directly adjacent meaning this one here would not be directly adjacent, but this one would be, and this one would be. The reason this pixel and this pixel is filled in is because we change our starting points to here and here, and then this image is this pixel is directly adjacent, this one is, and this one is, so it's all done recursively. We keep repeating this process recursively by checking neighboring pixels of the updated pixels, modifying their color if it matches the original color of the starting pixel, and then the process stops when there are no more adjacent pixels of the original color to update. And then we just return the modified image after performing the flood fill. So yeah, we're given two examples. Of course, if it's all set to 0, then we just return an empty image, and we are given some constraints as well. So obviously, the most obvious way to do this is using a depth first search / recursive method. And we can do this first with getting our starting node, or in this case, our starting pixel, which is going to be image sr sc. And we want to create our depth first search function. So let's say dfs equal to image sr sc color, as well as the starting pixel value, which we need to check if we should change the pixel or not. So what we need to check now is if it's in bounds. So if the pixel our add is in bounds. So let's say if SR is less than 0, yes, if SR is less than 0, or SR is greater than the length of the image, so it means it's gone beyond the number of rows, or SC is less than 0, or SC is greater than the length of image 0. Oh, we need to do -1 here for both of these because it's zero-based. Python is a zero-based programming language, so we do the length -1. And we also need to check if it's already set. So if our current pixel that we are at equals starting pixel, if it equals the color, so we want to skip this as well. Or if image sr sc does not equal to starting pixel, then we can just return, because we don't need to carry on our depth first search. We're out of bounds. The pixel doesn't exist in our image. It doesn't exist on frame, so to speak. But if we don't hit this, if we finish this, if we go past this if statement, we can say we need to change srsc to our new color. So we set it to our color, and then we do depth first search again for all the adjacent pixels. So passing our image again, srsc color, and our starting pixel. Let's make sure this is indented properly. And what we want to say here is we want to make it adjacent. So the one on top, pixel at the bottom, the pixel on our right, and the pixel to our left. And then up here, we want to call our depth first search function. So we can just copy this. So we'll start off with srsc, and then we're modifying our image directly because we're passing it into our depth first search function. So we can just return image. And let's run the code. And our solution is accepted. If we look at our submission, we can tell that it's quite an efficient solution compared to a lot of other answers that are given. So yeah, thanks for watching, guys. Bye.